Okay. All right, so we're gonna try and go back over 5-3, just to, you know, catch Rebecca and Rachel up and get you where you're going. Okay, the whole concept is the trig functions that we have, the sine, the cosine, the tangent, the cosecant, can all be put on our coordinate plane. And when we put them on a coordinate plane, we originally start out with what we call a unit circle. Okay, the unit circle means it has a radius of 1 all the way around it. Now, we also learned before that these are degrees. So this is 90 degrees, this is 180 degrees, this is 270 degrees, and this is 360 degrees. The other thing that we learned is basically if you look at a unit circle, and I'm looking for this point right here, which gives me the x and the y here. So this would be, of course, that point would be the x, how far over I went, and this would be the y, which is how far up I went. And we compare those to what your trig functions would be. So like if I'm standing right there, I'm going to put a theta right there. So that's the angle that I'm standing at. And so if I want to go, what is the sine of this? So this is y, this is x, and understand that's 1.
Okay.
So if I'm looking at the sine right here, I'm looking at opposite over hypotenuse. Okay, so this right here is comparable to my sine of theta.
Right.
If I'm looking at cosine and I'm standing right here, this is comparable to the cosine because it's adjacent over hypotenuse, which is your cosine. So this is x over 1, or this is the cosine of theta. So every time you have an x value, it's your cosine. Every time you have a y value, it's your sine.
And the whatever side.
Hypotenuse.
Yeah, it's always 1.
On the unit circle, we're going to
Okay,
change
this-
off of that.
okay.
We're going to change off of that shortly. But
Okay.
right now, everything is 1 there.
Okay.
So, like if they asked you, and we brought in special case triangles here, if they asked you for like the cosine of 45 degrees, then I go back to my special case triangles, which is x, x, and x on the square root of 2. Okay? So 45 degrees is right here. If I'm looking for the cosine of 45 degrees, it's equal to, I'm standing right here, adjacent over hypotenuse. So x over x on the square root of 2, that's equal to 1, but I have to rationalize the denominator. So I'm going to multiply it by the square root of 2 over 2. So I get the square root of 2 over 2. Therefore, I know that the cosine at 45 degrees is equal to the square root of 2 over 2. If I did the same thing for sine, the sine of 45 degrees is going to give me the exact same thing because it's opposite over hypotenuse, or the exact same thing I just did there.
Okay.
So the sine at 45 degrees is the square root of 2 over 2. Okay? Now you can do the exact same thing with a 30 degree, 60 degree angle. Okay? Now, the other thing is when they fall right here, you need to think about, that's the point 1, 0. This is the point 0, 1. This is the point -1, 0. And this is the point 0, -1. Okay? So if they were to ask me, what is the cosine at 90 degrees? Okay, cosine 90 degrees. Now remember, your cosine is your x. So the cosine is 0.
That's it.
Yes, my sine
Come on.
at 90 degrees is 1.
Okay.
If I were to go over here to the cosine at 180 degrees, what is my x value?
-1.
-1. My sine at 180 degrees is gonna be 0. Okay? If I'm down here, my cosine is 0, my sine is -1. Now, they might turn around and give me not things that are like that. Like in your book, okay, so number 14 on page 296, the sine of 90 degrees. So here's 90 degrees, what's my sine?
1.
1. Okay, now, did I give you all or did I? Yeah, I did.
All, yeah.
Okay, but then the next one says the tangent at 360 degrees. Now, there's my problem because what I found out was cosine of theta is equal to x over 1, or x over the hypotenuse. My sine of theta is equal to y over 1. And if I went back and I looked at this, remember tangent is opposite over adjacent, right? So my tangent is always my y over my x, okay? So if I'm looking for the tangent of 360 degrees, which is what number 15 is, my y over my x, or my 0 over 1, is going to give me 0, okay? So the tangent at 360 is 0. Then it asks for the cotangent of 180. Now you got to remember, cotangent is the flip of the tangent, so cotangent would be x over y. So if I'm talking -180, I'm talking right here, x over y is -1 over 0, which is undefined.
Right.
Okay? So that would be your answer for number 16.
Okay.
Then 17, it's the cosecant of 270. So you go, okay, where's 270 degrees? Now it's it's -270. So I'm going to go all the way around to here.
Okay.
And I'm looking for the cosine. So what's my cosine at -270?
0.
0, because cosine and x go together, sine and y go together, okay? I know it's weird, but it's
Yeah.
going to fall into place. It's a brand new concept. Okay, then I want the secant of 180 degrees. So now I'm back over here. Now secant is the inverse of the cosine. So if I flip that, I have 1 over the x, so I have 1 over -1,
Okay.
which is going to give me -1.
Okay.
Okay, does that make sense?
Yeah.
All right. Let's erase some of this up here. I'm going to leave my unit circle.
So how do you know where to always stand? Like the theta or
You are always right here at the origin.
Okay.
And so it has to do with, and really it's going to have to do with the reference angle. So it's going to have to do with where you are. Like if I had, let's say I had 90 and 45. So I had 135 degrees, okay? And let's say I wanted to know the cosine at 135 degrees, okay? So you're going, okay, that is that whole distance.
Okay.
But what I really need to look at is the reference angle there
Okay.
of what's left. Compare it to, remember doing the reference angle.
Yeah.
Okay, if this is 135, then that reference angle is going to be 45. But here's what I know, if this is in the second quadrant, then my x is going to be negative and my y is going to be positive. So my cosine is going to be negative here and my sine is going to be positive. So if I'm looking for the cosine at 135, remember I just did this special case triangle over there, and I found that my cosine was the square root of 2 over 2 and my sine was the square root of 2 over 2. Well, I know my cosine is negative and my sine is positive, so the cosine here is negative square root of 2 over 2.
Okay.
Okay?
Because that's the x.
Because that's the x.
Okay.
Yep. And right now you have to think about it. Eventually
Yeah,
you
we'll-
won't think cosine is x,
Right.
sine is y. Okay. Okay, again, I'm gonna put a unit circle. I wish I could just put it up there and just erase over top of it and then keep it on there.
Yeah, I'm sure there's like boards or whatever you can buy.
I
like a
would
graph
think
paper
so.
thing.
I don't know. I don't know.
I don't know where you put it.
I don't know. I guess you could get a marker board and put it on there since we use it so much. Okay, it says find, this is 20 on page 296. Find two values of theta for which the sine of theta equals 0. Now, so what I'm looking for is where the y value is equal to 0.
Okay.
So if I look here, you're talking here,
Uh-huh.
and you're talking here. So you're talking theta would have to equal 0, or theta would have to equal 180, or you could even have theta equal 360 to go all the way around the circle, okay? Or 720, or there's any
Right.
number of things that you could put there. Those are sample answers, okay? Then 21 says if the cosine of theta equals 0, what does the secant? Now secant, remember, is the inverse of it,
Cosine. Yeah.
of the cosine. So that's 0 over 1. So when I flip it, I get 1 over 0 or undefined.
Okay.
Okay? So that would be your answer for 21.
Okay.
All right. Then we got, and I'm going to do 22 up here, then I'm going to turn off the camera and I'm going to have you do the rest of
Okay.
them. And then we'll turn the camera back on and start on the other stuff.
Okay.
Okay, so on 22, on page 297, it says use the unit circle to find the values of the 6 trigonometric functions for each angle. So they give me 45 degrees, okay? Which means I'm right here, okay? Now remember, I've already done the 45, 45, 90 over here. So I know that x is the square root of 2 over 2 because it's opposite over hypotenuse. I mean, actually, it's adjacent over hypotenuse on cosine. Yes, no, maybe?
Wait. Oh,
Okay,
yeah, no,
I
you're
just
right, you're
confused
right.
you, I
No,
think.
sorry. I thought it was
Okay.
opposite too.
So if I have this triangle, maybe I'll do it right there. So this is x, this is y, and this is 1, right? Now if it's a special case triangle, then I know how these things are related.
Right.
This, and I think that's throwing you off there, because we use this as undefined. How about if I use a smiley face? Okay, smiley face, and smiley face on the square root of 2. Okay, that's how they're related.
Okay.
Okay, I think it might throw you, because we are using x as an unknown over there.
Yeah.
Okay, so then I go, okay, I have got smiley face. So if I'm looking for let's start out with the sine. Okay, we'll go through all of them. Sine, cosine, tangent. The inverse of sine is your cosecant. Oh, I forget the C. Your secant and your cotangent. Okay, those are the 6 things I'm trying to find. Okay, so I'm looking, the sine is opposite over hypotenuse. So, sine of 45 degrees is equal to, the opposite is smiley face, over smiley face on the square root of 2. Okay, now
Okay.
smiley face over smiley face is just 1, right?
Right.
So I have 1 over the square root of 2, which I'm going to rationalize the denominator, which is going to give me the square root of 2 over 2. Okay, so that is my sine. That's where that came from. Actually, that's my cosine. Okay, so I'll put the sine here. I've already put the cosine on there because it's the same thing. Because if I'm standing here and I do cosine, it's adjacent over hypotenuse, which is the exact same thing that I have there.
Okay.
Okay, so then I can go, okay, the sine of, and I shouldn't put theta because we know it's 45 degrees. Technicalities. Okay, so I have all that going down. So I've already got my sign. My sign is right there. So square root of 2 over 2.
Mhm.
I already have my cosine. I put it right there because it's my x, the square root of 2 over 2. Now my tangent is going to be y over x, or sine over cosine.
Mhm.
This over this, what does that equal to? If you have the same
1.
thing on the 1, okay? So that's equal to 1.
Okay.
Well, each one of these I'm going to reverse for that, but I'm going to come back over here. Because this is, the square root of 2 over 2 is the same as 1 over the square root of 2.
Okay.
So when I flip it,
Gotcha.
I get the square root of 2.
Yes.
When I flip this, I get the square root of 2.
Okay.
You know, because I'm just flipping this before I rationalize it. And when I flip that, I get 1.
Yeah.
Okay?
Okay.
All right, so I'm going to turn that off. I'm going to have you do them, and then we'll pick back up. Okay?
Okay.